Are getting going slowly. Okay, perfect. You should be good to go.
Cool, thanks, man. Welcome back to another VC Libraries video code review. Today, we will be looking at a pull request from our contributor, Misco, which is implementing a new feature. This is CXX23 feature. Implement P1425 iterator range constructors for stack and queue. So a little bit of background. We just finished CS+20. And our reward for completing so much work in such a short period of time is the standards committee has now voted in tons of new features to CS+23. And we are already beginning to accept pull requests for this now that we have the machinery and the compiler and our central library header that Casey added that defines a macro where we can detect the presence of the stood CS+ latest switch as distinguished from the new CS+20 switch. So now the doors are open for CS+23. We have a project tracking this. So the way to find this is you go to our GitHub repo, click on projects. The CS+20 project is now closed, and there is now a CS+23 features project where this has appeared. Let me open this up. And so features are categorized as available, investigating, but we don't have a PR yet. We're reviewing a PR, and that's the case for this one. Here's the associated issue for iterator pair constructors. Then there's comments for merging soon and done. So each of these issues, this is our way for tracking the work to be done. We just have a link to the WG21 paper, which I will open. We note whether it has a feature test macro or not. And this will be updated for certain once a new working paper is out. But we believe that this should be 2021-06 because they select the year and month when something was voted in. And then the actual paper. And then if any later patch papers or LWG issues have been voted in, we typically record those in the tracking issue so that everything is consolidated in one place. Additionally, you'll notice that there is a CS+20 defect reports project because the committee enjoyed CS+20 so much they can't stop working on it and have voted in a series of additional papers that retroactively change CS+20. This is the first time they've done so much of this, and we sort of caught them off guard because we kind of finished CS+20 before they did this. They were expecting implementations to take a bit longer. Surprise! Thanks to our contributors, we got done with CS+20 quite quickly. So now we need to implement and ship these features in the CS+20 mode. And there's already one PR out for that Casey's got, and we'll be looking at others in the future. But the one we're looking at today is just a plain old CS+23 feature. So let me close this. Okay, it's going to be cplib adapter iterator pair constructor. And then this here. Another way to find feature test macros is if you search for SD-6, or actually SD feature test is the better way to search. There is a standing document on isocpp.org that lists all the feature test macros and, importantly, why they're defined and if their values have changed. So like the spaceship macro CPP impl three-way comparison has gone through a bunch of different values because additional papers were voted in. I don't yet know if this has been updated for the iterator pair constructor. I suspect not yet, but let's see. That's adapter iterator pair. Let's search here. Adapter iterator. Okay, so it has not yet appeared in SD feature test because it is so new, but it will appear soon. They're quite good about updating this quickly. So I'll close this for now. Okay, so we've got the paper. Let me actually read through this. I'm trying to be a good kitty about actually reading the rationale before I go review the code. I've done it in the opposite order before, and that's not good. So this is going to modify what are called the container adapters. This goes back to the original classic STL, where you've got the fundamental containers. These are vector, dec, list, now forward list, map set, so forth, maybe string if you count that. Those actually store memory. But sometimes you just want a restricted, narrower interface. For example, if you are using a vector, but you're only ever pushing stuff at the back and then popping stuff, you're using it as a stack. So although it doesn't grant you any new functionality, it can be useful to readers and for maintenance to say, I am intentionally going to give up the full unlimited power of vector. And instead, I only want the very specific power of a stack. Don't even let arbitrary operations like indexing or arbitrary mid-insertion compile. And that way, when a reader sees a std stack, they know how it's going to be accessed. So std stack, std queue, std priority queue, which is a little different, they wrap or adapt an underlying container and restrict and sometimes modify its interface. Priority queue is different because it also calls the make heap algorithm. That's not being modified by this paper. And they're also customizable, so you can swap out the default underlying container for something else that supports the necessary operations, or a user-defined container that supports the necessary operations. Like if you have your own vector-like container, you can use that with a stack. So what's happening here is that these adapters are going to be given additional constructors. This is a before and after table. They're called Tony tables in honor of a committee member who sort of popularized this, although papers are often trying to avoid this term just because if you don't know who Tony is, it's confusing. So this shows what code would look like before and what it would look like after this feature. So previously, if you wanted to construct a queue or a stack from a range denoted by a pair of iterators like begin and end, you had to construct a temporary container of the necessary type, like a deck or a vector, and then give that to the adapter. Here, this is being cleverly done in the before code with braces, because the queue and stack have a constructor taking the underlying container. If you write braces here, this will implicitly construct a container, which will then be moved into the queue or stack. So that's kind of weird to have to construct with parentheses and then braces. It just looks very strange. What the feature does is it allows you to directly pass the begin and end iterators to the queue and the stack and have it directly construct the container within. So that's the motivation for the feature, sort of convenience. Many users would simply just expect this to compile. If you're constructible from a container, why not just be constructible from the iterators themselves, the way it's already constructible from a size? And it's got a little bit extra for deduction guides and so forth. So let's scroll down. This talks about like the history of the proposal and what's changed. But at this point, now that we know the motivation, I just want to see the wording. Okay, so this is the patch that's being applied to the working paper. If a new working paper were out, I would go switch to that and look at it. This has not yet been applied to a published working paper, so I'm going to be looking at the diff itself. This is okay because no later LWG issues or papers have been voted in that modify this thing. So you've got std queue. It's going to gain a constructor templated on first and last input iterators, and then another one taking an allocator. And if you don't pass one, then you'll get the default allocator used by the underlying container. And this range is for arbitrary input iterators. So they could be as weak as istrom iterators. They could be as strong as pointers. The adapter doesn't care. It's going to be passed to the underlying container, which defaults to a deck, but could be a list for queue, for example. Also, because class template argument deduction is a thing, or CTAD, because that's a mouthful, corresponding deduction guides are provided. If you want to learn more about CTAD, I have an entire CPPCon talk. I think this one was, I want to say 2018. I could be wrong. Look that up. I've got slides and everything. It explains what the feature is. But the idea is that it allows you to avoid specifying template arguments when you're constructing classes, when the compiler can deduce what you would want. Here, we need to provide a deduction guide because the type of the input iterator that's provided here is not directly related to the type of the queue that you would want. For example, your input iterator might be an int star, and the elements you get out of that are int. You would want a queue of int. But the input iterators might be my cool user-defined iterator, not obviously templated on anything. And when you dereference it, you get an int, and then you would want a queue of int. So the machinery to let the compiler know how to transform the iterator type to the type of the class during this class template arg deduction is done by a deduction guide, which is this sort of strange looking arrow thing here. A lot of CTAD works implicitly, automatically from the declarations of constructors. But when you need to do a transformation to the type like this, you need to provide a guide. So this says if you're constructing a queue using CTAD from a pair of input iterators, find out what the value type is if you dereference that input iterator and use that as the element type for the queue. So we provide this one line here, and then the compiler knows what to do. Similarly, for the one with an allocator, we need to customize the allocator type for the deck, and that's why we end up forming this type. Then the standard goes and defines what these constructors actually do. This part is fairly unsurprising. It just passes first and last to the underlying container, or if the allocator has been provided, passes it there. And similarly for stack, we gain the same kinds of constructors, first last alloc, and the exact same deduction guides. And let me double check. Stack is also backed by deck by default, so that's why the deduction guide uses deck. Okay, I believe that's all the changes. Yep, and then the feature test macro. Okay. The feature test macros, they were originally specified as being defined by the specific headers that provide features. And this is actually not super usable because it implies that if you want to know if so-and-so cool feature of stack queue is available, you needed to include the whole stack or queue header. Sometimes you wouldn't necessarily want to do that. The use case for that is something like Boost, where there's a sort of central Boost library, boost.config. It needs to go sense details of the underlying standard library implementation to define Boost's own macros. But if that thing had to then include every single STL header to look at every single feature test macro, that would be super duper bloated. So CS+ was eventually revised to something that's much more usable. It still is guaranteed that if you include stack, you'll get this feature test macro. So you can always just include the header that you want and then look at the feature test macro. But if you just want to inspect the feature test macros, you can include the central header called version. And then that will define all the feature test macros, any implementation specific macros, and hopefully nothing else, although that part's not guaranteed. It could drag in other stuff. But in practice, implementations will make this a very minimal header that has no runtime machine or anything, and that's true for us. For obscure and horrible reasons, we don't ourselves include the version header. We include something central called yvalscore.h, which is internal, but the version header does drag in all these feature test macros and basically nothing else. And so that means we can define the feature test macros in a centralized place, and then that will be picked up by stack and queue and whatever. So we don't need to pay attention to the headers in which they are supposed to also be defined. We put them in one place and they're dragged in everywhere. Okay, so with that preliminary explanation, let's actually look at the code. It's over here. We can close this project. Okay. Okay, and also let's read this. MISCO is implementing a couple other LWG issues, LWG 3506 and 3522. Let's read these. These are library working group resolutions, which are bug fixes applied to the standard. One is complaining about missing allocator extended constructors for priority queue, where priority queue, which always had a first last constructor, can now take alloc, optionally with compare in an underlying container, many different forms mirroring the existing forms. And the deduction guides are being changed to use not necessarily iterator traits, but this iter-value type. Okay, so we need to look at this. It makes sense to implement this, even though it's priority queue, because it's an adapter. Why not just do them all at the same time? And if this will ever load, maybe it won't. Oh, here we go. Missing requirement on input iterator template parameter for priority queue constructors. Okay, so another PQ. It says that a constructor template shall not participate in overload resolution if it has an input iterator and a type that does not qualify as an input iterator is deduced for that parameter. This sort of mysterious sentence prevents CTAD from deducing surprising and compile breaking things. I had submitted issues along these lines for map and the other containers back when we first implemented CTAD. And this is now appearing for priority queue. Okay, so when you see PQ changes, we'll need to look at these issues in addition to the original feature, which is over here. Okay, and I'll leave this open and I'll just move this. Okay, so let's look at the code. 269 lines added, 4 removed or edited. Okay, and I'm in side-by-side mode. I don't want that. Let's go unified, and yeah, we can hide white space if necessary. Okay, so let's minimize everything by alt-clicking the chevron. If I can do that on this trackpad. Okay. So we've got changes to the central header rivals core H and the feature test macro test as I expect. We've got the product code changes to queue and stack. Queue is bigger because we also got to modify priority queue. We're adding a new test, so good to see test list being added, and it's called P1425 R6, which does not seem to be the correct revision. Queue stack constructors. Is there an R6? I copied this number straight out of the accepted proposals. I don't think that's wrong. So I think that the R6 may be incorrect. Let me double check. In case some later revisions somehow appeared. I'm going to use the link shortener, wh1.link. If I ask for R6, does it give me 404? I'd be surprised if 2 revisions somehow appeared. Yeah, okay, so this doesn't exist. So the number is not correct. Okay, found an issue. And that may also affect YVal's core. Okay, let's look at YVal's core first. Okay, so the number here is actually correct. Okay, so that's good. This is in our CXX23 list. So we have a comment of the paper and what mode it's defined in, and then the feature test macro down here. So we've got the correct number in sorted order. We're calling the feature iterator pair constructors for stack and queue. That all looks right. And then the actual feature test macro. Always if and not if-def for these macros, because they're always defined to 0 or 1. Other macros are defined or not. This is a 0 or 1 macro. If underscore has 6623, matching comment, define cplib adapter iterator pair constructor to be 2021-06L. That value looks correct. Because the spelling of feature test macros is critical, I will double check this. Let's go over here. When developing code myself, I copy and paste like all the time to avoid retyping and potentially damaging stuff. Actually, I know I got it right here, so let me look at this. Okay, yes, that is exactly the correct spelling. Great. So YVal's core looks good. Let me expand this context a little to make sure we're defining the stuff in the right place here. So this is after the CXX20 region of macros. 23 going here makes sense. And then below, whoops, I'm using my trackpad. Below are the ones, the macros that all exist but vary according to standard mode. Sometimes between 17 and 20, sometimes 14, 17, 20. So this is the right location for new 23 stuff. Okay, so that's good. That's viewed. Let's check the feature test macro test. Okay, here. The only way this would pass is if this is all typed correctly, so I don't need to search for that. I do check that all the occurrences have been changed because I have found multiple times that search and replace has failed, and some have not been updated, but this all looks correct. 2021-06L. This is guarded by HES6X23. We conventionally don't comment this horrible block of preprocessor stuff. And the last thing to check is that it is in sorted order in this feature test macro test. ADA comes before ADD, so that's great. It's actually lexicographically first. Okay, so that's good. From memory, I know that there is currently no libcxx coverage of this, so no changes to the libcxx test. But now we need to report that the number is not correct. So let's actually let me just grab this from here again. and a comment. The paper number is R4. It appeared correctly in YVal's core H, but the revision number in the test name is different. Okay. The paper number is P1425R4, appeared correct in YVal's core H, but the revision number in the test name is different here. And obviously that affects the actual test code. Misco will know to rename that as well. And if these mismatched, like if this mentioned a test that didn't exist, that would fail in our internal test harness. However, not being mentioned here will silently succeed in our internal test harness. So that's why we got to remember at this time to make sure the test list is updated. This does appear in sorted order though, P1425, so that's good. That makes it easy to find tests. Okay, so test name commented. Now we've got the env list and test CP. I'll look at the env list real quick before we go here. Okay, so this env list is using the usual 20 matrix. I'm not convinced this is correct because this is a CS+23 feature. Yeah, CX623. It's not unconditional backport. I believe that this should be usual latest matrix. Latest is what we're calling 23 because that's the compiler name. I'm going to check the actual definition. Yeah, this is guarded by if has CXX23. How is this even compiling? Because this is passing tests right now. Our CI is currently using VS2019 1611. Oh, that one didn't get the backport. Okay, this is related to a real fun merge history for MSVC where we added and removed and restored a switch. I believe 1611 has both std CS+20 and std CS+latest, and I want to say both of them activate CXX23. I'm not actually 100% sure. But this still seemed to be incorrect in the PR. Oh, that's taking a while.
I don't believe that's correct. I think it has both flags. They define the correct values.
Okay.
C++20 should be 2020-02 and C++23 is 2020-04L.
Okay, you made that change, so I assume you're correct. So but then that's really interesting. Like, how is this possibly working?
I'm curious.
So in GitHub, the test list isn't used at all. All the tests understood simply run. And then I should actually look at the test. Maybe it's maybe it's guarded by
conditional in the test code, maybe.
Yeah, something like that. Here we go. Oh, it's actually guarded by if has CX623. Okay, well that explains why it's successfully compiling. But this should not be necessary. Like a test for a CXX23 feature should not say pound if has CXX23. You should just assume that we're in CS+23 mode. And instead the, maybe I'm speaking too soon. Instead the test list. However,
Steph,
the only case should know that.
If you look at the Q header file, there are some has CXX23 regions and CXX20 that are being added in some enable FTs that are specifically not guarded. And it looks like not all of the test is guarded with the CXX23.
Yeah, good point. Yeah, I think you found why. Great catch. Because he's also doing those LWG issues. And this is priority queue. This is totally unconditional though. This is happening all the way down to CS+14 mode. And then, yeah, the PQ constructors, here he's guarding has CXX20. I think that's because he uses allocator. This is relatively recent. I can't remember how recent. Maybe that's why it's 20. Usually we implement LWG issues completely unconditionally, but occasionally they affect recently added tech, and that's why it's more guarded. Let me see. Open up the STL. Actually, I shouldn't click that. It's I'm going to just open up a plain editor. Oh, I may be asking my computer to do too much. Come on. Sometimes VS Code will open up the last open project, and this should be the STL project for me. Oh, it is STL. Yeah. What was I going to look? I was going to look for uses allocator V. No, I don't want to drag. Okay, lots of existing usage, and it's not too surprising. Okay, the fact that it's marked as inline var indicates that it's CS plus 14. Yeah, this is unconditional. Yeah, there's no guarding around here. Okay, so this is interesting. Switch back here. Okay, so this explains why the test was using the 20 matrix. Okay, thanks, me and Casey. But what's going through my head is, why is this not unconditional? This LWG issue, should we implement this all the way down to 14 mode and then make the test use the usual matrix, which goes down to 14? Because I see nothing here that's specific to 17 or 20. Like, we had make heap back then. We have uses allocator. This is using enable if and not any sort of concepts. Let me look at the LWG issues again. Yes, just add a bunch of constructors. The deduction guides use the iter value type stuff, but we already have centralized machine for that, and deduction guides are always guarded for 17 or above. So the deduction guides need to be 17 or above, but the constructors, I think they can be unconditional. This thing is for CTAD. In fact, the constraints are for CTAD, but it's okay to have them even if you're in CS plus 14 mode and there's literally no CTAD, because then the enable if will always succeed. So I think this is an issue. Let me do one more scan before I get a comment and look really silly. Yeah, iter value t, this underscore iter value t, this is unconditional. All this stuff should work in 14 mode. Okay, so I'm going to add a comment. Or should I add the comment? I should probably add both so we don't forget. Whereas the plain queue and stack should be 23 for sure. Yeah, but the priority queue should not be. Okay, so let me find the first occurrence of if has CXX20. Yeah, here. Okay. Let's see. Why are the LWG issue resolutions guarded for CS plus 20? Unless I'm missing something. This would all compile in CS plus 14, 17 modes, and we usually, I'll actually say almost always, implement LWG issue resolutions unconditionally or as or back to the oldest standard where they would possibly make sense. Yes. Okay. I'll ask, can we make this unconditional? Okay. Why are the LWG issue resolutions guarded for C+20? Unless I'm missing something, this would compile in, which I do need to mention the deduction guides. And the guide should be 17, not 20. Okay, let me add that as a separate comment. No, why make separate comments? I'll just make a single comment. That way Misko doesn't have to apply to all this stuff. The deduction guides would then need to be guarded for CS+17, earliest standard with CTAD. The test would need to use the usual matrix and the appropriate parts of the test, or corresponding parts. The test would need to be unconditional, priority queue construction tests, or guarded for CS+17 CTAD tests. Okay, see if that makes sense. Why are the LWG issue resolutions guarded for CS+20? Unless I'm missing something, this would compile in CS+14-17 modes, and we almost always implement LWG issue resolutions unconditionally or back to the old standard where they would possibly make sense. Can we make this unconditional? The deduction guides would then need to be guarded for CS+17, earliest standard with CTAD. The test would need to use the usual matrix, and the corresponding parts of the test need to be unconditional, priority queue construction tests, or guarded for CS+17 CTAD tests. Okay, I think that's everything. Okay, cool. Okay, let's go back. Okay, so we've got our copyright license banner and pending comment about the matrix, but otherwise is good. And the test has copyright license banner. We don't yet have automation for this, so I always manually verify. We'll look at the test after looking at the product code. Okay, let's, we've looked a little bit at Q. Let's look at stack before going back to Q, because stack has more focused changes just for CS+23. Okay, so we're seeing the iterator constructor, the iterator alloc, and then the deduction guide. It's one of them at the bottom. Okay, and everything here is guarded by CX623 as expected. Okay, so let's read this. Really should have this side by side, but it's actually small enough I can probably just memorize what it is. This will render. Where's the stack? There we go. Init first last alloc, and then corresponding deduction guides, and this one needs to fill in the deck and the alloc. Okay. And position wise, although I think for the container adapters, we still declare stuff in a jumbled order. I'm not going to pay too much attention to following a standard declaration order here. That can also always be changed later because it doesn't affect ABI. It does look like he's following, which is great, the declaration order. Where's this one? Yeah, it's like after container ref and stack ref const alloc, container ref stack ref. Oh, okay. Misko's exactly following standard order. Much appreciated. Okay, let's look at the actual definition. Okay, so pound if underscore SCX623 end if. Yep, that matches. Okay, so we've got template on class init, input iterator. It's constrained to participate only when it is an iterator. Okay, where is that constraint coming from? Is that a global wording for stack that was then patched? Because that constraint is not depicted here. I don't see that in here. Do I dare open up the standard? It's going to be too slow. Let's open up the HTML standard. Yes. Draft. Okay, so this would be containers, and then adapters, container adapters, stack, class template stack. Go. Okay. Okay, the constructors with allocators are specified to be constrained for the container type needs to use the alloc, so we should expect to see that. Nothing about anything else though. Oh, but we're now adding the iterator thing. It didn't even have a constructor with iterators before, so of course there would be nothing. So is there global? Because there's not wording being added in this paper. Oh, is there global container-wide wording? I vaguely remember this. Like all the stuff we did in CS17 is coming back to me. Where would that live? It's either container requirements or container sequence. Let's just look at this here first. Okay. Requirements, scroll through the table, get an allocator. Come on, you can render. Okay, this is exception handling. This is how stuff is allocated. Aha, this is the sentence I was thinking of. The behavior of certain container member functions and deduction guides depends on whether types qualify as input iterators or allocators. Oh, this simply says what it means to determine if something can't be an input iterator. Okay, something else is going to hook into this that says if you're templated on this, you should be constrained. Could have sworn we had global wording, maybe sequence container. Here we go. This is what I'm thinking of. For every sequence container defined in this clause and in strings, if the constructor init first, init last, maybe with an allocator, is called with the type input iterator that does not qualify as an input iterator, and that refers to the wording above, then the constructor shall not participate in overload resolution. This prevents CTAD, because that's the only, that's the case that's really affected by this, from getting confused by this init first, init last signature when other constructors would be more preferred. There's a potential like LWG wording defect here because this said for every sequence container, and the adapters are not actually containers, they're container adapters. I think technically this doesn't apply, but morally it does apply. Like it totally should.
You're correct that it doesn't apply, but there's a separate paragraph. Container.adapters.general/4 has similar wording for container adapters.
Oh, wonderful. Thank you.
Yeah.
They've thought ahead. Okay, great. So that's where this is coming from. And it's excellent that Misko has it here, because otherwise I could have easily missed it. And it's not depicted in the paper, so very easy to miss.
Okay, sure so it has it on the constructor instead of the deduction guide, though.
Because the constructor always generates an implicit deduction guide, even if there's a specific deduction guide that we want. And we don't want the constructor to go mess up. We had this issue all over the place in MAP, where even though we want the deduction guide to like totally replace the constructor, that's not the way the core language is phrased. So you need to constrain the constructor if you don't want it to go stomp over everything. CTAD it's a nice feature. It's very useful. I think so some people have said, oh, CTAD's bad, don't use it. I disagree. I like CTAD. And generally implementing stuff to use to work with CTAD is fairly easy, but as is often the case with CS+, the corner cases can be surprisingly complicated, and deduction and the overload resolution is one of them, especially when you have sort of very generic things. And this is actually specific to fusing old code with CTAD. In the new world, especially the ranges world, where stuff is properly constrained, this is much less of an issue, because if the stack constructor is constrained to only accept iterators, then you don't need to worry about it deducing this stuff for like integers and whatever. But because this is totally unconstrained, we need to manually add a constraint here. Okay, so if it's CXX23 endif, template on init, enable if t, because we conventionally use classic VNA unless we absolutely have to use concepts. Init needs to be an iterator into 0. Okay, that all looks good using our usual conventions. Stack constructor takes init first and last. And then we are strengthening it, because we do this for all the constructors, to be no except when is no throw constructible v the container from our values of type init. And that is correct because we're moving it. Okay. I think, let me look at the actual paper. It is technically not correct, I think, to move first and last into the container, because this depicts it as passing L values, but really it's okay to move. It's there probably should be global wording somewhere. This is, we can move iterators whenever we feel like it. If we are, because ranges is increasingly paying attention to what if an iterator is expensive and moving it is more efficient. This is much more classic CS+98 STL wording that doesn't care about value categories. The STL does pay attention when it's like a container, but we're still developing discipline for iterators. I think it's okay to move. I wouldn't even mention it as a library issue, although I think technically it is one. Move first, move last, and there may actually already be global wording. I don't know. I know it's like not going to cause bugs for like 99.999% of users, which is why I'm not even interested in looking it up. Construct the container C with this. Okay, so that's good. Nothing else. Don't need exception handling or anything. We've already got the conditional no except. That looks great. Okay. And then down here, we've got another constructor. If underscore has CXX23 endif, matching comment, template on class init, class alloc, and then enable if when the conjunction of things is true, init's got to be an iterator, and uses allocator, container alloc. Yep, that's good. This is more specific than just are you an allocator? And this is the same constraint aside from the variable template versus class here, as we've used elsewhere, so that's all perfect. Stack taking init first and at last. Here I'm always monitoring for ugly names, even if I'm not mentioning it. And then we take a const alloc ref al. This is also strengthened with conditional no except. Is no throw constructible v the container from two inits that are our values and a const alloc ref. Okay, that's all correct. Construct C, move first, move last, sort qualified, and al. Okay, great. And then the deduction guide. This, I believe, was listed in the paper, whoops, as two separate deduction guides. Yes, but it is okay to fuse them into one with a default argument. The user will certainly not notice because it has no runtime impact. So I think that's okay. Okay, so here, no, I don't want to select. And this is still the CXX23 feature, so CXX23 is the correct guard. Template init. Alloc will default to an allocator for the iter value t of init. And that should sphere if init is not actually an iterator. And then we enable if, conjunction, init's got to be an iterator, alloc's got to be an allocator. Here we don't use the uses allocator container because we don't know the container. We're actually going to form the container deck using this alloc. So the only constraint possible is alloc even remotely resembling an allocator. So that's good. Stack two inits. We don't need to name the parameters because we're not actually going to use them. And then an alloc that defaults to alloc paren. I believe this is the one of the few cases in the STL where we still use parentheses to construct temporaries because it's technically observable for allocators. Stack back by iter value t for init. The deck container using the same element type, and that allocator. Is there any other parameters? No, that's all the parameters. Okay, so that deduction guide looks good. Done with header. Let's look at Q now. Okay, so Q, very similar for the 23 feature. If underscore CXX23 endif, same comment. Template init, enable if, init's an iterator. Yep. Q init first, init last. Strength and no accept is no throw constructible. The container from init. Yep. C, move first, move last. Looks good. Next constructor, if underscore CXX23, end of matching, template init alloc, enable if conjunction iterator init, uses allocator container alloc at 0. Yep. Here I'm on the lookout for like copy paste errors because those are so tempting. I don't see any. Q, init first, init last, console alloc ref al, conditional no accept strengthened, is no throw constructible container from 2 inits and a console alloc ref. It's important to have, when possible, the exact same value category and consonants. Here we are passing an L value of type console alloc ref, so that's all good. Construct C from move first, move last al. Yep. And then the deduction guide for the 23 feature. Okay, correct guard. Same pattern, init, alloc defaults to allocator, iter value to init. Enable if conjunction V, init's got to be an iterator, alloc's got to be an allocator-ish. Q from 2 inits and alloc defaulting forms a Q for the iter value t init, backed by a dec again. Iter value t. I had to double check that that is the default for both of the types, so that we don't accidentally form the wrong backing store there. Double check here. It was maybe I should. Where's that Q? Yeah, Q defaults to dec just like stack does. Okay, and then now the LWG issue resolution. So let me look at these. So the small one was just oh, this is the one that's this must be related to the standard use case found. This is what's saying for all the container adapters, constrain them for input iterators. So this is what's providing. Okay. Yeah, and yes, the upcoming paper. Okay, so we have handled this for the new stuff. And any existing constructors in the priority queue, their input iterator should be constrained. Okay. Then this one is the one that is adding 4 constructors, taking 2 inits and then alloc with possibly a compare before or a compare and a possibly R value container before, because default arguments, we're going to insert them in the middle. And then the deduction guides are being changed, and it depicts this here. We only need 3 deduction guides because this one just takes the container by value. That's how we can decay it. It's a cool CTAD trick. Okay, so in priority queue, let me expand some of this. This is implementing those iterator constraints. No args, predicate container. This one takes inits, so we add the constraint enable if t is iterator v init into 0. That's great. This is unconditional, so that's great. LWG issues should be unconditional. Yep, here, same and same. That's all good. And then we get into the allocator stuff. Okay, these don't have any inits, so no changes there. And then already got the question about why is this stuff conditional on 20? I think Misco was probably just thinking about all the 20 backports that we're doing, which is all those issues, and then just added this here. But I think it really should be down to 14. Okay, so now let's look at this. Okay, so I'm pausing here because I'm seeing iterators, but I am not seeing the constraint. I think that's missing. I think all these puppies should also be constrained for inits with the conjunction technique. And it doesnn help if the guides are constrained because we've got to do the constructor. So I believe that's a bug. I will add a comment here. If my trackpad will let me. I don't want to zoom. No, okay. Okay, here we go. And what issue was that? That was 3522. Copy paste this. See, according to LWG blah, all of these priority queue constructors I'm taking in it should be additionally constrained by, what were we using? Is iterator? Is iterator. Iterator. So I think we need to conjunction the, was it 4 of them? 1, 2, 3, 4? Yeah, all 4 of them. All 4 of them. Okay. According to LWG 3522, all these priority queue constructors taking init should be additionally constrained by is iterator. So I think we need to conjunction V all 4 of them. Okay. The order here does not match the standard or the stuff being voted into the standard, but I suspect it may match the existing implementation where we had, no, we didn't do it here. I don't care about the order so much. Casey, what do you feel? I know you care about the order matching the standard. Is that worth a comment?
If you're going to ask for something else to change, then sure.
Okay. I'll add a comment. Then yeah. So what is the order? No, I scrolled too much. Oh no, it was the LWG issue. Alloc, compare, const container ref. Yeah, definitely not the same order. I'll add a comment here. Let's see. As there are no order dependencies between these constructors, it would be nice to follow the order depicted in LWG 3506. Okay, so that out of the way, we've got init alloc, enable if t should be is iterator and also uses allocator v container alloc. Okay, that's good. Priority queue from init first, init last. And let's check the parameter order here because I don't trust my memory. It's always const compare ref, and then maybe a container, and then an alloc. Okay. Const pr ref pred, const container ref cont, const alloc ref al. Okay, that's all good. Construct C with copy the container and copy the allocator. Construct our comp with the pred. Okay. And then let's look at the definition, even though it's pretty simple. Add the following paragraphs for the container one. Insert at end first last, and then make heap. Okay. It's so interesting that this is depicted as insert at end rather than just directly construct the container. Oh, no, it's because we're given a container and then we have to add it first last. That's why we're inserting. Okay. So construct the container, C insert at C end from first to last. I observe that this is copying. But this is definitely how we write the other constructors. I'm okay with this constructor not looking like the newly added CS+23 ones, because this is more consistent with, or is this consistent? I think this is consistent with the existing ones. Don't we have a first last somewhere? Or was that, I thought we had at least one first last, but we don't. No, we do. It's just the ones not taking alloc. Where are they? Oh, here they are. The existing constructors pass first last and not move the iterators, so it is more consistent within this class to not use move, and I like local consistency, so that's good. Okay, and then we stood make heap to avoid ADL, give it C begin, C end, and our comp. It's good that we're using our comparator rather than the provided one. Okay, that looks good. Now the one that does not take a container or a pred, template init, alloc, we've already talked about the constraint, take first, last, const alloc ref al. Okay, so this one, let's check the definition. This is here. C with first, last, and al, value init comp, and then make heap begin and comp. That is the one I'm looking at, right? Yes. Okay, so construct C with first, last, and al, value init comp. This is necessary because comp could be a function pointer. Or sorry, that would be bad. Comp could be something where garbage in it is bad and value in it is good. That way. And then std make heap, C begin, C end comp. Yep, that's good. Okay. And then if you take a pred, that's this one. Should be first, last, A, comp with compare, and then make heap. So same signature, add the const pair of pred there. C with first, last, al, comp now with pred, and then std make heap. Yep, that looks good. And then the final one where we move the container. Okay, same signature. We take container ref. We move the container, very important. And pass the al, comp with pred, insert an n first, last, and then make heap. Yes, that's all good. And then string the guard, which you've already talked about. Mystical note update the comment there. Okay, and then guides. Only 3 guides, as we mentioned. The cool decay trick. Okay, so in an allocator should default to vector, which is the default before prior to Q. If you get the compare, you should put that at the end instead of less. Okay. So if it's 20, now this is conjunctioning, so this is all good. Template on iter, alloc, enable if t, conjunction v, iter's got to be an iterator, alloc's got to be an allocator. Excuse me, prior to Q, iterator, alloc, deduces prior to Q, iter value t iter, vector of iter value t iter and the given alloc, and then less iter value t iter. Okay. This actually did depict less. It did. Okay. Honestly, I don't know why the standard doesn't just depict stopping here and let the priority queue provide defaults for these, because these are the defaults if you just provide the oh no, sorry, this one needs to be customized, the allocator. I don't know why the standard doesn't stop here, because it should totally default less, but it's okay to spell it out in full. And then since the standard says so, just following that in the implementation is fine. There's no need to introduce additional divergence because it doesn't really save us a whole bunch of work. Okay, template on iter. Ooh, you're not ugly. Compare should be ugly. Curs below, also for container there. Got to think about the poor users who are macroizing compare and container. Or more likely having some third-party library do so. Okay, template class underscore iter, class compare, commented, class underscore alloc, enable if t, conjunction v, iterator iter, allocator alloc, prior to q for iter, compare alloc, deduce prior to q, iter value t, iter, vector of iter value t, iter, and that alloc, and then the user given compare. Okay. Then template class under iter, talked about compare, and container class under alloc. Enable if t, conjunction v is iterator iter, is allocator alloc. Yep, nothing to constrain about the container. Wait, where is there? This actually takes a container. Can we constrain on alloc being the right allocator for the container? Where would that appear? That's not mentioned here at all. Okay, so this is interesting. The other ones didn't have this sort of take a container and then also append stuff for it. Is there global wording? I need to go back to the standards about uses allocator. Let's see. Containers. No, too far. I don't want vector. No, stop. I want to scroll. There. Adapters. Probably in general. Here we go. This is the sentence I was thinking of. A deduction guide for a container adapter shall not participate in overload resolution if any of the following are true. When it has just an allocator, we look at, are you possibly even an allocator? But if you have both container and allocator, then you need to ask, hey, container, do you even use that allocator? So that needs to be using uses allocator V. Let me get that citation because it was hard to find. It's the global wording that implies implementation stuff that is not depicted at the local point of the declaration is like always the stuff that's easy to miss, especially for the containers which are in the adapters which are so highly centralized. Let me double check that this didn't apply to anything in Q, and we know stack looked exactly the same. Yeah, this only takes an allocator, same with stack. Does not take a container, so there's no opportunity to uses allocator. So it's specific to priority queue. Whenever I see an issue I'm about to comment on in a CR, the first thing I ask is, wait, did I already blaze through 5 occurrences and didn't notice it? Do I need to comment on many of them? So this means that we looked at the first one, the container alloc, and did not notice. Oh no, sorry, this one is right. This is uses allocator container alloc. Okay, so it actually is. Let's check all these. Uses allocator container alloc. Yep. Uses allocator container alloc. Uses allocator container alloc. Oh no, sorry. These are the constructors I'm looking at. I want the guides. Guides. Here we go. Iter alloc. Okay, only alloc is allocator. Iter compare alloc. Okay, all we have is this allocator. But iter compare container alloc. This is the one that needs to be using allocator. Okay, so only one line. Not comment here, so let me, yes. Okay. According to paste, we need to constrain with uses allocator because we have both uglify container and alloc here. Okay, gotcha. Template, iter, compare container alloc, enable if conjunction is iterator iter, and then uses allocator, container alloc and 0, priority queue, iter, compare container alloc, deduce priority queue. Then what are we deducing? Grab the value type from the container, then the container and the compare. Type name, container value type, container compare. Okay, so that part's good. And then okay, so that's product code. Now on to the test. Only 159 lines. Should be fast. Okay, so copyright license, a bunch of headers in sorted order. Okay. And then we've got some test data. Some data is 0 through 5. Additional data is 6 through 11. We've got a custom allocator. It provides value type, default CDOR, rebinding CDOR. Here I'm going through memory, extensive memory of what allocators are needed to provide. These are provided, or these are specified by the allocator requirements in the standard. Allocate constructs an allocator of T. We've included memory and allocates N. Deallocate also makes temporary calls that. This provides a construct but not a destroy, templated variatically in args. Why are we providing this? this is what the default does. There's no destroy, there's no instrumentation. I assume he's using this just for, just for deduction. Is that right? Oh yeah, because we need to call container, or we need to construct containers with this. And possibly it occurs in deduction guides. Yeah. Here we're deducing that it had better be custom allocator, which is why he's not using std allocator, because that wouldn't, if we forgot the allocator type and just use the std one, we wouldn't detect it there. But we don't actually need construct at. This is the defaults provided, same as a lot of other machineries just being defaulted here. This can just be dropped. No, I wanted a multi-line comment. Yeah, it can be a single line comment, but it's got to be on construct. Come on, cancel. I believe that construct can be omitted. The library will provide default machinery, and nothing in this test appears to need this function like that. Okay, I believe that construct can be omitted. The library will provide default machinery. Nothing in this test appears to need this function. Okay. All the rest is necessary, and we get the default rebinding behavior there. Okay, that looks good. Technically, we don't get equality. We do need equality to satisfy their container or the allocator requirements. I'll comment on that. Very semi is kind of a silly place to comment that. I'll comment on the type. We additionally need to provide operator equal, accepting custom allocators of different types. I was thinking, oh, in CS+20, we only need equal. But in CS+14 and in 17, in CS+14, 17, we also need to provide operator not equal to satisfy the allocator requirements. Okay. Yeah, this is out of long experience where we had a lot of allocators that didn't really meet all the requirements, and then as we increasingly improved the STL's implementation and required more stuff, our test started to break, which is real annoying. So it is good for long-term maintenance if tests strictly provide all the requirements of the standard, even if we don't need them today, just so that they'll continue working in the future and we don't need to go fix up dozens of years of tests. Okay, so we got the allocator. Now we are going to test the constructors. Template on a range, test container, make a range from begin of some data, end of some data. That's our context array. We're going to have an int result that we're going to assign to. In CXX23, let's test these new constructors. So use ctad for the stack S1 from begin end. Static assert that the declared type of S1 is stack of int, dec int allocator int, that the size is the S1 size is the size of some data, which is the size of the range. Set the result to be 5 because we expect 4. Is that right? Or no, 5. It's 1 through 5 to be the last element. Yep. As long as S1's not empty. Okay, so here he's repeatedly looking at the top and then popping to check all the elements. And so that's why post decrement is used. That's good. This is our convention is to prefer pre-increment and post-increment. Sorry, our convention is to prefer pre-increment and pre-decrement by default unless we specifically need the post forms. This makes the post forms stand out more. Here, a post form is being used and it's necessary. So this is good. Okay, so that looks great. And this is because the stack interface has specifically restricted us from just looking through the entire container or adapter at once. Okay, next. CTAD stack S2 from begin end and a custom allocator into temporary. Make sure that we get the right type. Yep. Again, should be size of some data. Result 5. And then here I'm making sure that we keep saying S2 and it'll go back to S1, so that's good. If we wanted, we could add extra braces to scope this stack. The danger is not really high in test code of accidentally referring to the other one. I won't ask for that. But that is a pattern that appears in other tests. Then we do the same for Q, Q1, Q back by dec. It's the size of some data. Okay, so here we're popping from the front of the queue. So we start at 0 and then expect increasingly large things. So that's all good. Fun fact, many people, when they look at the stack queue interface, they're like, why do you have separate pop and top, and why not just combine them? Why not just have a pop that returns the element? And the answer is due to the STL's focus on efficiency. If you wanted to pop an element but didn't care what it was, maybe you already knew what it was, you're just discarding it, returning it could be a performance cost. I think this was more significant back in the 90s and late 80s when, or I guess 90s for the STL. Less significant these days to have a return value that you don't care about. But that's why they were split into separate functions. Q2, CTAD from custom allocator, inspect its type, that we should get it. Yep. Size should be some data. Again, always looking at Q2. Okay, that's all good. And then the priority queue tests here are unconditional, so that's good. Here he is always using CTAD. So if you wanted to make the tests down to 14, that would be a problem. I would be okay with the product code being unconditional, and kind of okay with the product code being unconditional and the test being 17 only, but really, like, to be strictly, comprehensive, the product code should be unconditional, and then the test code should use CTAD only in 17 or above, and for 14 we should write out the type, which is not too hard. You just have if-defs, and I already mentioned that in the comments that that's already taken care of. So prior to Q, we're going to test the 4 constructors. PQ1, range begin, range end. Yep, this is the type that you should get out. Should be size of some data. And then, well, it's not empty. Here, the priority queue is going to heapify it, but then return it in sorted order. The stuff was already sorted, so it's unsurprising that we're going to get them in this order. Okay. If we provide the allocator, we should get that reflected in the type. And then same as we pop, yep. If we provide a comparator, then it should be reflected here, greater int. PQ3 size, look at all the values coming out. Okay, that's good. And yes, when you use greater, it's opposite order. So instead of 5 counting down, we get 0 counting up. So that's good. Now we're going to have a vector using CTAD, starting with our additional data. Okay, and we're providing a comparator. This is an L value. I'm mentally going through all the constructors and asking which one am I calling. Stack assert that we get the right type. Yep, the greater int. And PQ4 size should be the size of some data plus the size of the additional data that we constructed the vector of. And then, because they have been cleverly designed to be all from the same sequence, we can blast through the priority queue in a single loop and count up from 0, so that's good. PQ5 uses a temporary vector. Here he's spelling out vector int, allocator int, which is fine, because that does appear in this type here. So I'm okay with even though it is the default, it explicitly appearing here. Priority queue, begin end, greater int, begin additional data, and additional data, so that's good. Okay, we get the type. Count up, okay, it's all PQ5. Vector container 2, named with the custom allocator being used for CTAD. Okay. And then here we pass as an L value, get the type, look at PQ6, yep, that's all good. Then PQ7 is an R value container. So yep, we're testing all the overloads, all the CTAD. And this is all PQ7, that's good. Get the right type. Okay. And then we're gonna try to construct from various powers. Forward list is forward only, the weakest container in the STL. Dec, which is random but not contiguous. Vector, which is contiguous. Set, which is bidirectional. Usually, yeah, personally, I would usually say list, forward list, dec, vector. But set is fine here. It works with everything. It's actually sort of an interesting stress case, so that's cool. There's no coverage of actual input-only iterators. I think that's okay. We're certainly, like, nothing in the adapter code is directly handling the iterators. It's just being passed to the container, and the containers have extensive coverage of iterator powers. There's really nothing to be gained by adding an iStream iterator or having a, the ranges machinery, which has custom iterators. I don't think that would add a lot of value. Not worth the effort. I can't, with all the STL bugs I've seen, I can't imagine that we would get something wrong for input iterator here. So I'm okay with this. Okay, I think that's it. I don't see anything else here to comment on. We've looked at all the files. We're not adding new headers, doing anything that requires us to make far-reaching changes. Overall looks great, just a few issues that need to be corrected, so I will request changes. Okay, submitted successfully. And checking that all my comments have appeared, if they will render. Yes, and it's to work in progress, great. I will now deassign myself, which we use to track who needs to take action on this. Okay. Okay, I think that does it for this review. Does anyone have questions or things they would like to mention that this review inspired them to think about? I guess I can mention the iterator, the container adapters are pretty cool. I think I first used them at the sort of very beginning of my CS+ journey. It was when I was implementing data compression and implementing the Huffman algorithm, where you need to build a bunch of nodes representing symbols like bytes and their frequencies that they've appeared, and then you recursively glue together nodes, make larger nodes with their combined frequencies, and then you're constantly looking for the lowest frequency remaining nodes. And a convenient way to do that is with a priority queue. You can just say, I want to priority queue nodes, and then I can just repeatedly push and pop, and it's always going to get me the right node. And so that's where I learned the ordering the priority queue uses. I can never remember it, so I always have to look up, wait, do I get the biggest or the smallest element? Do I need less or greater to reverse it? That's just a sort of convenient introduction to the world of the heap algorithms and containers and container adapters. I've used stack and queue less, but occasionally it isn't. They are useful when you're doing something and you want to, pop them in order. It's nice to sort of restrict yourself down. Cameron, I see you have your hand up.
Yeah, so I actually have a similar story with using these container adapters. I use priority queue as well, but it was for a completely different reason, which was to implement a A-star pathfinding algorithm for a tower defense game I was making back in university. So that's cool. That's when I first found out that, the STL just kind of had most of the things that I need. And these container adapters are like really nice and abstract, and they do exactly what you expect.
Yeah, that's awesome. Yeah, and as Charlie says, these sort of things, A-star and data compression, just sort of general algorithms are a great way to learn CS+. Plus, they're amenable to unit testing. Okay, I think that's everything. So we can call this a successful video code review. Thanks everybody for watching.
There's also a question here in the log from
question,
Cameron that he didn't mention.
So
He's asking why there's no Q constructor which can take iterators of different types.
You mean iterators like a iterator sentinel pairs, basically? Or something else.
Like you have like a sentinel end or something like that.
Yeah, so my understanding, and Casey can correct me if I'm wrong, is that this is sort of a global issue throughout all of the classic containers, container adapters, and algorithms, that they always take iterators of the same type, and they expect to do so, and they have not been generalized to the CS+20 ranges world of arbitrary iterator sentinel pairs. I am not sure if they could be. One concern would be throughput. If you go, modify the existing stuff to activate the new ranges functionality. There are some concerns, I think, around potentially overloading, but I think those are probably not primary because I accept two iterators of the same type, constructors and functions. They need to deduce the same type. Trying to give them different types will just fail at the deduction stage. And there's now wording in the standard that says, you can't pass explicit template arguments to functions, and you certainly can't to constructors. So I think that would not be a roadblock. I think probably it's throughput. I can't imagine other potential downsides. There's some concern about, I guess the other concern is for some of the algorithms that are heavily overloaded. The reason why they're unambiguous is actually because of the pattern of I take two input iterators of the same type. That sometimes disambiguates them. I'm thinking of std sort and things like that, where the specific pattern of template arguments means that in practice, all of the potential function calls are unambiguous, even though some of them have the same arity, the same number of parameters, and especially with constructors would end up being heavily overloaded. But possibly that could be worked out. The committee would need to do that work and make sure it's not heavily breaking. But I could see that happening in the future. Casey, is there anything you can add from the ranges perspective?
I can expand on that maybe a teeny little bit. There's kind of a fear of overloading double iterator things with iterator sentinel things. But what I'd like to see in the future is if we could relax the constructors that we have on containers, container adapters, from taking two things of the same type to taking two things of different types, and then having a requirement that they're either two things of the same type that meet the old iterator requirements, or they're two things of the different type that happen to model the new range requirements. And the library presumably would then be written to work on the intersection of those two sets of requirements to make it work invisibly behind the scenes. But that's a future work that I have not had time to look at yet.
I think that makes sense. And plus, since we control the constructors, we can constrain them and their guides sufficiently so that they don't stomp on each other. For the free functions, it's a little harder because they could potentially be running overload resolution against user-defined functions, but the constructors are a more sort of self-contained environment. Okay, I think that's everything. So thanks, everyone. See you next week.
Thanks, everybody. I'll stop the recording.